Hi there, Ms. Heaton signing in to talk with you today about the metric system. This is something that you're probably familiar with, but we're going to be dealing with it for the rest of the year, so it's really important that you pay attention and make sure you learn the following things. The goal today is to recognize the primary measurable quantities in the metric system, the units that we'll use to describe them in the metric system, and how metric units are related to one another. And this is also mentioned in your textbook, pages 18 to 21, so check that out as well. So the metric system you may be familiar with if you've watched the Olympics before, because this is used primarily throughout the world. Just about every country except the US and to some extent England have switched over to the metric system. They no longer use pounds or feet or Fahrenheit. They use these units. For measuring mass, they use kilograms or grams. For length, they use meters, represented by the letter N. For time, they use seconds, which we do as well. For temperature, they use Kelvin or Celsius, which we'll talk about in Unit 3. And in volume, for measuring the amount of liquid, they measure in liters instead of measuring in ounces. Why would we want to use the metric system? Well, the main reason is that it's based on the number 10. So it's really easy to express a number that you're measuring in either kilograms or grams or decigrams or milligrams, because each of those conversions are based on 10. Whereas in the system that we use, the conversions are always different. 12 inches is 1 foot, and ounces and quarts and cups, I can never keep it all straight. And for inches, like within inches, it measures in like a 1/16 of an inch. That gets a little crazy. If you want to check out a funny video about that, if you've ever seen the show American Chopper, it's about these like really buff, manly motorcyclists, and this is them trying to figure out how to convert from quarters of an inch to 1/16 of an inch and having a really hard time. So check it out. It's also posted in our Google Docs. Here are the metric prefixes that we are going to focus on in this class. I've actually listed all of the main ones here, but you can see some of them are crossed out. You do not need to memorize those, although they are also important, but the primary metric prefixes that you will encounter in chemistry are kilo, base units, which could either be grams, liters, meters, any of those units we just talked about. And then for quantities that are smaller, they might be measured in deciliters, decimeters, decigrams, centigrams, milli, or nano. So make sure that you copy down this chart. And what we're going to do is go through and talk about each of these prefixes as they relate to the base units. And for that, we'll write an equivalence statement, a statement that says how the kilo is related to the base unit. So let's start with that. Kilo or kilo, you may have heard of before. You may have heard of this if you've ever watched like CSI or something where they're talking about kilos of drugs. A lot of times if you catch a drug dealer, they're going to have lots and lots of drugs. And so a kilo is used to measure quantities that are very large. Also, if you run track, you may have heard of the mile. Well, it's actually measured in meters. It's the 1,600 meter run, or a 1.6 kilometer run. Or if you run longer races like a 5K, the K stands for kilo, and it means 1,000 of the base unit. So if you have 1,000 meters, if meters is your base unit, you'd have 1 kilometer. If you had 1,000 grams, you would have 1 kilogram. If you had 1,000 liters, you'd have 1 kiloliter. Now, if you're measuring smaller quantities, one more thing about kilo. You may have heard people talking about houses. Usually when we talk about houses, you might say that a house is worth $300K. That means $300,000. So that's how you can remember that kilo means you have 1,000 of your base units. Deci, you may have heard of the decimal. Hopefully you have by now. A decimal is the 10th place in a number. And that's because deci means 1/10 of the base unit. So it takes 10 whatevers to make one whatever. So it takes 10 decimeters to make 1 meter. It takes 10 deciliters to make 1 liter. It takes 10 decigrams to make 1 gram. For centi, you've heard of a centimeter, hopefully by now. You've also heard of cents. In a dollar, there are 100 cents. In the same way, in one base unit, there are 100 centi whatevers. Milli. This is kind of like a millipede versus a centipede. A millipede has 1,000 legs because 1,000 milliliters, 1,000 of those really small things, add up to make one of your base units. So 1,000 milliliters is 1 liter. Micro, we won't use a whole lot, but it does have this really awesome mu symbol. It kind of looks like a U as its symbol because there's so many other M's already in the system. And that's 10 to the 6th or a million. And then nano. You may have heard a lot about nanoscale things. This is really where a lot of cutting edge science is being done. 1 nanometer is a really, really, really tiny amount. A nano, well, to make 1 base unit, you need a billion, or 10 to the 9th, nano whatevers. Typically, we deal with nanometers. So 10 to the 9th, or a billion nanometers, is equal to the length of 1 meter stick. That's a whole lot of nano. If you'd like to see a little video clip about how small or big each of these quantities are and how they're related, check out YouTube Powers of 10. It's this awesome movie made in the 70s. This is also posted in our Google Docs account, so check it out there. Okay, folks, that's basically the metric system in a nutshell. Make sure that you've memorized all those prefixes and how they are related to the base units. What I suggest you do to memorize it is to write out the 6 equivalence statements for all 3 of the base units. That'd be 18 equalities in total. If you can memorize it without doing that, great. If not, get to work.